Cheers! Advancing stewardship practices when controlling pests and growing plants.
Sprinkler irrigation is an essential practice for growing high-quality vegetables and strawberries on the Central Coast. Sprinklers have many uses: pre-irrigation, germinating newly planted seed, post-transplanting, growing the crop to maturity.
It's essential when managing sprinkler irrigations that the system operator takes advantage of the tools and practices available to minimize field runoff from sprinklers. One important reason to do this is to minimize the potential for pesticides, nutrients, fertilizer, and silt that may run off from cropland on the Central Coast.
Efforts are underway to make pesticide applicators aware that products applied to field are being detected at measurable levels in Central Coast waterways. Detections are found by water monitoring being done as part of the state-mandated Irrigated Lands Regulatory Program. Whether samples are taken during the growing season or winter months, pesticides, fertilizers, and silt are being found in waterways, sometimes above allowable levels set by regional and state water regulators.
Admittedly, controlling water runoff from torrential downpours is difficult. However, during the growing season, when rainfall is not a factor, there are practices that can help minimize or even eliminate field runoff from irrigations.
Combining proper pesticide application management with good irrigation practices for an agricultural site can significantly help protect water quality. Michael Kahn, Irrigation and Water Resources Advisor for the University of California Cooperative Extension in Salinas, has spent decades studying ways to help growers manage and minimize runoff from fields.
Growers are very interested in trying to reduce the amount of runoff they have in their fields. It's both a food safety issue as well as a water quality problem. And in many locations, we don't have a lot of water available, so they want to use that water as efficiently as possible.
Dr. Kahn describes two main approaches for mitigating the impacts of farm inputs on waterways: minimize irrigation runoff and retain, treat, or dispose of runoff. One of the fundamentals to minimize runoff is designing an efficient system that allows for even water coverage of a field.
When a system is designed and laid out for optimum uniform distribution, water is applied evenly across a field. That means you're not overwatering one side of a field and leaving the other side dry. An overwatered section of a field can be a source of water runoff. Tracking how much water is applied and soil moisture content are also good practices to ensure that water is applied evenly across the entire field and soil isn't getting too saturated.
When we're operating sprinklers, they will start producing more runoff when the soil becomes saturated. So a good indication when you need to turn those sprinklers off is when you see a significant increase in the volume of runoff.
This shows a field close to runoff. This field has been irrigated enough to match crop water need at emergence growth stage. This lettuce is just emerging. It's been watered for about an hour. This field has been watered for an extra 2 hours, and the soil is clearly oversaturated with visible runoff. One technology seen more often in Central Coast vegetables is drip irrigation. When systems are well maintained, drip irrigation proves to be an effective tool for both optimizing yields and virtually eliminating field runoff. While drip is most widely used for in-season irrigation after starting the crop with sprinklers, some growers are having success using drip for crop germination.
Instead of using sprinklers for establishing crops, we can bury the drip before planting and germinate up the crop with the drip tape. And this minimizes any runoff you would get from sprinklers during establishment.
Under certain weather conditions and soil types, drip holds the most promise.
This method of drip germinating crops is ideal for soil types that would be sort of a silt loam to sandy loam texture. They're ideal in areas where you would have very windy conditions and you wouldn't get good uniformity with sprinklers. They are ideal in soil types that are prone to crusting because you have to irrigate very frequently just to keep that crust wet.
No matter which type of irrigation system, every grower knows the struggle with ongoing system maintenance. In some fields, system leaks can turn into significant field runoff events.
Whether it's a sprinkler system or a drip system, we often see leaks. The irrigator that's very prompt in repairing those leaks can greatly reduce runoff. An example of leaks that we see commonly in drip systems is that the lay flat that's on the surface that connects to the drip lines, often that connection comes apart and we have a major leak. So those leaks, if they can be fixed promptly, we can greatly reduce the runoff that we would be associated with the drip system.
Another basic practice is ensuring that the sprinkler system has solid connections between main lines and laterals. Even after a system is set up with a good design and there is still field runoff, what can be done with that excess water? After all, what attracts attention of water regulators is when pesticides, fertilizers, or silt are carried in field drainage to waterways, and that's what we want to manage.
One option for reducing field drainage is building on-farm holding ponds or sediment traps. These ponds collect excess water routed by way of field-drained ditches. There are different types of basins used to capture runoff.
One is a sediment trap, which is a shallow basin and drops out the large size particles that would be carried in runoff, but this is limited in capacity. At the lower end of the ranch, we might have a larger basin that allows water that's draining from multiple fields to come into it, and then that water can be pumped back up to the top of the ranch.
Ideally, the basins are located an adequate distance away from fields growing crops where there are food safety concerns with ponds in the vicinity. In some instances, treatment of the pond water is needed. Retention basins aren't without challenges. First, they need to be designed large enough to hold most or all of the drainage from a field or ranch. And silt accumulation has to be managed. Silt must be cleaned out periodically to maximize water holding capacity of the basin.
A practice showing promise is running field drainage through ditches built along field edges planted with dense grasses.
A vegetated ditch is simply a ditch that's been vegetated. We try to use grasses that are small seeded so they don't attract rodents. What the vegetation does is slows down the flow of water. That way the very fine sediments have time to drop out. It also allows pesticides to be captured on that vegetation. Many pesticides like to stick to organic matter, and the vegetation provides that organic matter for the pesticide to be retained. The vegetated ditches that we've tested are able to remove about 90% of the pesticides that are flowing in the runoff.
Vegetated ditches have another advantage. Much of the water flowing through the ditch soaks into the soil, minimizing the amount of water that runs off into streams or other water bodies.
The vegetated ditches not only help in reducing the concentration of pesticides and dropping out sediment in the runoff, but they also can infiltrate a good portion of that runoff.
An effective vegetated ditch is fairly simple to construct and needs to be maintained to perform at its best. The ideal vegetated ditch is
shallow sloped, so it may take some engineering to reduce the slope of the banks to say a 1-to-3 or 1-to-4 ratio.
Once the ditch is built, it's important to select the right grasses to plant in the ditch for Central Coast growing conditions.
One of the ideal grasses that we've used is red fescue. It's a native grass. It grows very densely. It does not go dormant during the winter. It will treat stormwater runoff. It also holds the soil in place, so we have very little erosion, even during very large stormwater events.
Studies in Salinas Valley have shown reductions in sediment load of almost 90% with properly operating vegetated ditches. When the vegetation is lush and well maintained, it can serve as a natural filter for pesticides and nutrients carried in the water.
One practice to get even better performance from vegetated waterways is installing wattles or construction socks filled with biochar or activated carbon. These socks are placed perpendicular to the water flow in either a vegetated ditch or a regular drain ditch. Typically, they are spaced 50 to 100 feet apart down the ditch, depending on the flow. The pesticides bind to the material in the socks, and by slowing the flow, allow sediments to drop out and water to soak in the ground. The socks also can remove most, but not all, of the pesticides dissolved in the water and not bound to sediment. The advantage of putting the socks at the lower end of the vegetated ditch is that they are less likely to clog with sediments because most has already settled out.
Periodically, the socks need to be disposed. Carbon socks must be taken to a landfill. Biochar socks can be applied to a field and plowed in with normal tillage or incorporated with compost.
We have tested both activated carbon and biochar as a carbon filtration treatment for runoff, and we find both methods, both materials, are very effective in sequestering pesticides and treating pesticides.
Water regulators are taking a hard look at the water running off of irrigated cropland. They can measure farm inputs at parts per trillion in the drain water and will take actions against growers and operators if impacts to water quality are not addressed soon.
It's no longer a question of if water regulations will become stricter, but rather when.
The question for growers and irrigators: how can field drainage be slowed or eliminated most effectively in each unique field situation?